Hi everyone! Today I'll be talking about binary classification AI models. We'll explore how binary classification works, the key algorithms behind it, how we evaluate performance, and how to choose the right model for a given problem. Binary classification is one of the core tasks in machine learning. It's used to sort data into two categories, like spam or not spam, disease or no disease, fraud or genuine. The goal is to train a model that can learn from labeled examples and make accurate predictions on new, unseen data. It's used in countless real world applications from email filtering to medical diagnostics. Let's start with one of the simplest and most widely used models logistic regression. It predicts the probability that something belongs to one class or the other using a logistic or S shaped function. It's easy to interpret and fast to train, which makes it a great baseline model. However, it assumes a linear relationship between features and the output, which isn't always true, and it's sensitive to outliers. Support vector machines, or SVMs, take things a step further. They find the best boundary, or hyperplane, that separates two classes with the largest possible margin. SVMs work well even in high dimensional spaces and can handle nonlinear data using kernel tricks. They're known for being robust and accurate, but can be computationally heavy for large datasets. Naive Bayes is a probability based model that uses Bayes' theorem. It assumes that all features are independent, which makes it fast and efficient even with small datasets. It's especially popular in text classification, like spam detection or sentiment analysis. However, that independence assumption doesn't always hold, which can hurt accuracy in some cases. Decision trees are another core method. They split data into branches based on feature values, leading to decisions at the leaf nodes. They're very interpretable. You can actually follow the reasoning step by step. That's why they're used in fields like finance, marketing, and healthcare, where understanding the why behind predictions matters. Random forest takes the idea of decision trees further. It builds many trees on different random samples of data and combines the results. This reduces overfitting and improves accuracy. It's powerful and can handle large, complex datasets, but is less interpretable and more computationally expensive. K nearest neighbors, or KNN, is one of the most simplest models conceptually. It looks at the k closest data points to a new sample and assigns the most common class among them. It doesn't need explicit training and adapts easily to new data, though it can be very slow for large datasets. When we evaluate binary classifiers, we look at several key metrics. Accuracy tells us how many predictions were correct, but can be misleading in imbalanced data. So we also use precision, recall, and the F1 score, which balance true positives and false negatives. The ROC AUC curve helps us understand how well the model distinguishes between classes. In real life, datasets are often imbalanced, like having many normal cases and very few frauds. This makes models biased towards the majority class. To fix that, we can oversample the minority class, undersample the majority, or use synthetic data using techniques like SMOT. Adjusting thresholds and metrics also improve fairness and recall. To wrap up, start simple. Logistic regression is a great first choice for interpretability. For more complex problems, SVMs or random forests handle nonlinear patterns better. Always evaluate carefully, iterate, and tune hyperparameters to match your data and domain needs. Thank you for listening. Binary classification models are a large part of modern AI, and choosing the right one can make all the difference.